with the other 6 is no problem. The idea behind this method, ya shabab, is let's say that we have a function. Let's say that we have this function, and this is the x-intercept. This is the real zero. So we have y equals f of x, and we want to find where the x-intercept. We need to find the real zero. The real zero, you know that it means the x-intercept when the function is 0, when y is 0. Newton came up with a brilliant idea. Oh, let me make it a little bit curvy like this. Okay. What he said, let's start from here. I will start with a point. Let's call it x1. I will choose a point here, approximately. This is what is called a first approximation. Usually we use this by guessing. We find this, or we choose this value by guessing. Just guess a value. Of course, the sketch of the graph, you can also make a rough sketch for the equation of the function, and you can estimate it from there, approximate it from there. So we usually x1, it will be given for you, or you can choose it by yourself. We will see together how to do that. Now we will start with a point with a number x1, and of course here we have a point x1 and the value of the function at x1. What Newton said, I will make a tangent line. I will draw a tangent line, or I will find the equation of the tangent line, and then I will draw it. And the x-intercept of this line, so this is, ya shabab, the tangent line. The x-intercept of this line, let's say x1, x2. We have x1, this is x2. This will be the second approximation. Notice that it is closer to the, let's call this one R. This is the solution that we are looking for, or the x-intercept that we want to find. Now, this is a good approximation, better than x1, because we are close now from R. Now, again, repeat this process. So here, this is x2. What you will do, you will find the the tangent line here. Find another tangent line. If you let me draw it this way. This is another tangent line. Notice now that this tangent line is more close. This is the x-intercept, x3, let's call it. It is more close to the root that we are looking for. So we can say that, for example, that x3 is approximately equals to R. When we make a shabab x4, x5, and so on, we will get more closer and closer if this algorithm converges, not diverges. And we will see that together. So it is important for you as a college students to understand the idea behind this method. It is illustrated here for you, Shabab, also in the slides to make sure that you will not forget it. So to solve, Shabab, what is the idea is to solve such equation that as I told you. So this is, for example, the second approximation x2. Then you will use the equation. You remember how to write the equation of a tangent? This is the equation of the tangent line at the point x1, the equation of this tangent line. Now, if you take, if you approximate it now, if you take x2, and you know at x2, y is 0, so you can just use this point to find the another approximation. So since x2, it is the x-intercept of this line. So at x2, if at x2 will be 0. I'm talking about the line here, the equation of the line, the y here will be 0. So this is why we wrote this one to be 0. Now solve this equation for x2. What you will have? Divide by this, by f prime of x1. You will get the following equation. Then move x1 to the other side. So you have now a formula. You already have x1. x1 is given, or you choose it from the beginning. Now you have x2. What is x2? It will be x1 minus f of x1 over f prime at x1. From where we obtain this, Shabab? From the equation of the tangent line at the first approximation. If you repeat that again يا شباب for x3, طبعا this is a second approximation. If you repeat that for another point here, you will get another approximation. It will be like this: x3, the third approximation, will be x2 minus the value of the function at x2 over the derivative of the function at x2. If you repeat this process n times, let's say, then the xn plus 1, it will be xn minus the value of the function at xn over the derivative of xn. If you want to find xn, the one before this, what it will be? It will be xn minus 1, the previous one, minus the value of the function at the previous one over the derivative at the previous approximation. Is the idea clear, Shabab, for you? All what you will use is this formula. Just you need to make sure that the derivative is not 0. If the derivative is 0, this means that the line is horizontal and it is impossible to have x-intercept. So avoiding, try to avoid having this denominator equals to 0. So we don't want the derivative to be 0 at any number of, at any approximation. This is why I said, Shabab, this section is very easy, because you need to do only, or to use only one formula. This is the formula that you need. Okay, so let's start. When n goes to infinity, when we do a lot of approximations, when n goes to infinity, in the usual situations or in the normal situations, the sequence converges. This algorithm will converge, and it will converge to R, to the root that we are looking for. Let's start. This is also important for you, that although the sequence of successive approximation converges to the desired root of functions, in some situations it is not. Like this. Look here. This is a graph. If you start with, well, let's say a bad guess. You start with this x1, but look here, when you draw the tangent line, where will be the x2? X2 will be farther. It will be farthest. It will be so far. Largest the distance now. It is not close to R. It is in fact more far from R. And if you repeat that process again, this is the x-intercept. Find the value of the function at x2. So this is the x2 and the value of the function at x2. Now, if you draw a tangent line at this point and you find the x-intercept, look at x3. It is more and more far away from the exact x-intercept that we are looking to approximate. So this is what is called that, what we say that the sequence of approximations is divergent. It diverges. It's getting further and further. So this is what we have if we start with a worse approximation, let's say. Because we don't guess, especially here, if you notice that the derivative at this point, it is almost 0, close to 0, because we have like a horizontal line. The tangent is a horizontal line. So it might even happen that the approximation such as x3 falls outside of the domain, because the domain is from here to here. Sometimes even it will go out to be impossible value, outside of the domain of the function. So the Newton's method fails, and a better initial approximation should be chosen. It depends on the first choose for the approximation. It depends on the first approximation. Let's start with the same example that Newton used to explain his idea. What Newton did, he considered this equation as a good illustration for his method. So what he did, he said, let's start with this equation. Now let's assume that I want to find the solution or the real 0 of this equation. And he started with x1 equals to x2. After several tries, ya shabab, he didn't get this easily. In fact, he tried x equals 1, and then, for example, tried x equals 3, and several values. And he found that the best initial guess to start with is this x equals x1 to be 2. Now, usually this will be given for you, or it will be clear for you to choose it within a specific interval. Now, let's find the third approximations, not all the approximations. Just let's find the third approximation to the root of this equation. So what we will do, ya shabab, we will put this, equals to what? A function. Let's call it f of x. Clearly, this is a polynomial, very easy. This is the derivative. Now, we will do what? We will apply the algorithm. Remember, this is the Newton methods. This is all what you need to remember. Now, what we have? We have x1. We need to find x2. So what will be x2? x2 will be x1, the previous approximation, the value of the function at the previous approximation over the derivative at the previous approximation. Now, in general, here it is, in general for any n, but we don't want it for any n, ya shabab. Just we will find it for x1 and x2 and of course x3. So for x1 equals to 2, what will be x2? x2 will be x1 minus the value of the function at x1 over the value of the derivative at x1. x1 is 2, so this is 2. And here you will substitute on the function, here it will be f at 2 over the derivative at 2. So here is the function, this is the function, evaluated at 2. What we have, shabab, at 2? What is the value of the function at 2? It will be 8.
-1.
-4, -5. So it is what? It is
-1.
8 minus 4 minus 5. Let me do it for you. I don't know why they don't write here. So what is it, shabab? -1. Over, what do we have here? 4, 12, 10.
minus 2.
It will be 2 plus 1 over 10, which is what? 21 over 10. This is what we ask you to do. Of course, you can write it as 2.1. No problem, 2.1. Usually when you need a calculator, we will not ask you questions that has long calculations. So now what is this 2.2, ya shabab? It is the second approximation. Now we are assuming that this more closer to the root more than x1. Let's do the next approximation, x3. What will be x3? x3 will be x2 minus the value of the function at x2 over the derivative at x2. The same process, but for the second one. So here it is. And of course, even here, ya shabab, you don't need a calculator. We will not ask you to use a calculator. You can do it, of course, here as a fraction. As I said, 21 over 10. Then, of course, you will try to cube it and multiply 3 times and simplify that. No need to find it approximately. But if you notice that it is also very close to the first guess that we start with. So this is why it was very good approximation to start with. Usually we will give you questions or that can be found easily, especially when you start with a good approximation. Let's go to the next example. Example 2, use Newton methods to find the square or the sixth root of 2 correct to 8 decimal places. So what we will do, if you have a calculator, you can do it, but here we are just mentioning the Newton methods. But we want it to be correct to 8 decimal places. So what will be the idea? You will write, let's call it x, the square, the sixth root of 2, it is x. So we want to find what is x. Okay. Now what we will do, we will write it as an equation. So you will move this to this side. So it will be x minus this root over equals to 0, which is this one. Now this is an equation that we want to solve. So let's call this one a function. Let's call it f of x. And what we will do now, we will apply Newton's method. And he mentioned Newton's method. By the way, we can use for some functions, we can use the ideas that you learned before. You remember the differentials, the rate of change, Also, you can use rules, theorem. There are many methods, but here we are talking about the Newton's method. What we will do next, we will find the derivative. This is the derivative of this function. Now, we need to start, Shabab, with a good approximation. We need to start with x1. What do you think? What is the best number to start with? Let's start with what? Yes, I think it is a good approximation. Yes, because the sixth root of 2, it will be close from 1. I'm sure. It will not be طبعا. For sure, Shabab, it will be a number between 1 and 2. It will not be even 2. Impossible. So even it will not be 1. So it will be between 1 and 2. So it is a good idea to start with what? This is of course the algorithm, Shabab. This is the algorithm that we will use. Now what we will do, we will start with 1. It is a good idea to start with 1. So what you will do, you will just apply this algorithm, Shabab, here. So for example, what will be x2? Here it is. It is mentioned here. x2 will be, let's do it, Shabab, together. It will be 1 minus the value of the function at 1 over the derivative at 1. As you know that x2, it is x1 minus f of x1 over f prime at x1. Now this will be equals to what? 1 minus the value of the function at 1. What is the value of the function at 1? Negative 1. If you put here x equals to 1. Over the derivative, here is the derivative, it is 6. So it will be what? X plus 1 over 6, all of 6. It will be 7 over 6. So for us, we will ask you about this number, not about this. Even if you can do it by dividing, of course, to have that one approximately. Okay, so I think I need to add these steps here because it is not mentioned in your book. Now you will use this, Shabab, as a second approximation now. 7 over 6, it is equals to x2. You will use it to find what? x3. And you can do that similarly. This is x3. Then x4, where you will stop. He wants he wants it to be accurate or exact until 8 decimals. So when you notice that for example, here like 1, 1, 6, here it is 1, 1, 2, here it is 1, 1, 2. So these 2 digits are fixed now. They will not be changed. You can, if you find the second one, look, it is 1, 2, 2. Now we have 3 digits or 4 digits now. 4 digits you stay the same. If you continue that, you can notice that if you notice the last x5, this is x4, this is x5, and the x6, look at these. Now we have 1, 2, 3, 4, 5, 6. Like all of these digits are the same now. They will not be changed. So this is the good approximation. So we will say that x5 and x6 suggest that to conclude that approximately the 6th root of 2 is this. And we got it early indeed, just at the 5th approximation. It will be the same. When we find x6, we found that it is the same as x5. So no need to continue. If you continue, you will stay close from this number. Let's take another example here. And this is, of course, I found it in the old exams. They mentioned such example like this. Again, approximate the 0 or the root of this one. Cosine x equals x. For x, what is x here? When cosine x equals to x. طبعا for sine we know يا شباب, sine x equals to x. This is when we are very close from what? When we are very close from, طبعا we are talking about radian. When we are very close from 0, because you know that limit sine x over x when x goes to 0, it will be what? It will be 1. So when we have very small numbers, we will have this property. طبعا when we use, of course, radians. Now to solve this equation, what you will do, Shabab? What is the trick? Who can tell me? What we will do? What is the first step?
Put it on one side.
Okay, eliminate one side. So this will be equals to 0. Next, call this one
f of x.
f of x. خلاص, you got it. Now what you will do, you will find the first derivative of this function, and this is the first derivative. Now we need to start with a good guess, ya shabab. What is the best guessing to start with? Approximation. What do you think? طبعا the algorithm, if you think about how it will be, x1 plus 1, it will be like this. And of course, we need to start now with x1. What is x1 that we can start with?
0.
طبعا when you solve such a problem, يا شباب, you need to set your calculator to radians, not to grades. Degrees, I mean. Not to degrees. You need to convert it to radians when you solve such problems.
3 pi over 2.
Yes. Again?
3 pi.
3 pi over 2. You can think about make it much easier if you. I think the best way, Shabab, I told you before. I said that you can start by guessing a value or by making a rough speak or a roughly speaking sketch, a rough sketch. If you remember the graph of cosine, at 0 it is 1. At pi over 2 it is 0. It is like this. Sketch the graph of this equation and sketch the graph of this equation. This is y equals to cosine x. This is y equals to, let's do it this way. This is y equals to what? To x. You can see, Shabab, that where is the intersection points, and when they are equals each other, we need cosine x to equals to x. They will equals to each other like here, some number between 0 and pi over 2. So if you say 3 pi over 4, it is not a good approximation. So it will be a number here. I don't know if it is 1. We can say 1, like 1, because pi over 2 is what? Is 3.1 approximately, 3.14 over 2. So it is 1.6, something like this. So it is something like here. So if we start with 1, I think it is a good approximation. We can start with 1. No problem. Let's see what he started with. He started with 1, yes, as I expect. So I think here the graph is much better than mine. So it is some number here. We don't know what is it. Approximately it is 1, but of course don't forget to set your calculator to radian before doing any calculations like this. طبعا you can do يا شباب also on MATLAB, for example, on other applications. You can make of course an algorithm to calculate that. So don't forget to put your calculator in radians mode. And x2 will be what, Shabab? If we calculate it, let's calculate x2 only. It will be x1 minus the value of the function at x1 over the derivative at x1. So x, in our case, it is 1 minus the value of the function at 1 over the derivative at 1. So it is 1 minus, what is the function? The function, it is cosine. 1 minus 1 over the derivative. The derivative is negative sine 1 minus 1. Now, to find cosine 1, it should be in radians, ya shabab, not in degrees. To find sine 1, you need a calculator. So you need a calculator to solve such equation like this. Let's now, that's it, ya shabab. This is 4.8. Let's have all the exam questions to see how it looks like. Yalla, Shabab, 1 minute to solve this. I will give you 1 minute. It is in fact more than enough because he wants you here to use Newton's method, and he gave you the initial guess. He gave you the first approximation. The second, we want just the second approximation only. We want x2. This is x1. What will be x2? Yalla, Shabab, and I will set a polling for you to choose the right answer. You can solve it in 1 minute. Let's take 2 minutes, no problem. Please, Shabab, try to take a paper and pen and start solve. Please, practice. طبعا يا شباب, as you remember, 4.7 and 4.8 and also inshallah 4.9, they will be on the quiz of the next week. we will try to have these 3 sections in the last long quiz, inshallah, if we are able to have it, inshallah, next week. As we have agreed, it will be on Tuesday. If we didn't finish 4.9, we can also postpone it to Thursday. We will see what we can do. But my main aim is to have quizzes over all the sections of the course. So we don't want to miss any section.
Doctor, did you put the polling or?
Yes, I did.
Because it's not.
It's not agreeing with you, Ibrahim?
Yeah.
Strange. I can see that some students are already chosen. We have like 9 students already chosen.
Look on post. Try to.
You can write it on the chat, no problem. If you are not able, خلاص, it's okay. No need to write it even on the chat. Just write it down on your paper and check your solution at the end. You can check your solution later. So, mashallah, 19 students, like 50% of the students participated. But you shabab, you still, of course, not agreed about specific answer. I can see now that, mashallah, A, B, C, D, E, all of you choose several answers. Again, shabab, this section is a gift. Yani 4.9, 4.8 and 4.9. They are very easy sections. And if you got questions from these 2 sections, you are lucky. They should be the grades of these sections should be inside your pocket. You will not lose any point here. Just you need to apply the formula here, the method, the Newton's successive approximation. So let me share with you, shabab. Let me end the polling and share with you the results. 5 students went with A, 11 with B, 6 with C, 2 with D, 1 with E. And of course, ya shabab, the right answer is it is B. The answer is B, and it should be clear, ya shabab. Now, we have equation here. What we will do, we will eliminate the right-hand side. So it will be minus 4x plus 2 equals to 0. We will call this f of x. Okay? Next, we will find the derivative. This is 3x squared minus 4. Now, what we want x2. x2 will be x1 minus the value of the function at x1 over the derivative at x1. So it will be what? 2, because x1 is 2, minus f at 2 over f prime at 2. This equals to 2 minus, what is the value of the function at 2? Substitute here. What it will be? It will be 2 to the power 3 minus 4 times 2 plus 2 over, and don't forget that this is minus for all. Here we have the derivative. It will be 3 times 2 to the power 2 minus 4. This is equals to 2 minus, what do we have here, Shabab? 8 minus 8, 0. So we will have 2. Over here it will be 4. 4 times 3 is 12. 12 minus 4 is 8. So it will be equals to 2 minus 2 over 8. It is 1 over 4. And this is 4. 2 times 4, it is 8. 8 minus 1 over 4, it is 7 over 4. So easy. Let's take another old exam question. And it is with a little bit trick here. Small trick. But it will not be hard for you, I'm sure. If Newton's method is used to find the critical number of this function with initial approximation x1 equals to 0, then the third approximation equals to what? Yalla ya shabab, I will give you 3 minutes. Since he said x3, I will give you 3 minutes, no problem. So the trick is here يا شباب now. Up to here. What is that? Who can tell me? Think about it. Think about it and then tell me. Let me also share with you a polling for this question. Who got the idea يا شباب? Who got the trick of this question? What you are thinking about يا شباب? Share with us your thinking. Salman, he will get it. I need another
to
one.
find the derivative.
Salman, I'm sure that you will get it, Salman. I'm sure. Thank you, Salman. I don't want you to disturb your colleagues' thinking. But if there is no one answer, I will go back to you, Salman. MashaAllah, you are a superhero in this course. Anyone, Shabab? طبعا MashaAllah, Salman, he is one of the students that he skipped the prep year and he is doing very well in Math 101. MashaAllah, tabarakallah. Abdul Aziz, who has an idea? Okay, Salman, let's share with us your idea, Salman, because we don't have much time.
The critical number is the zeros of the derivative.
Allah yarda alayk. Sahih. The critical numbers are the zeros of the derivative or the values at which the derivative does not exist, but this is a polynomial, it exists everywhere. So what we will do, ya Salman, what do you suggest?
So first find the derivative.
إذا أول شغلة راح نسويها يا شباب إن إحنا نجيب الدerivative. Okay? The derivative of this function is what?
6x to the 5
squared to the power 2 plus 2x minus 2. وبعدين
then from Newton's method we should get x2 and x3.
we need it equals to 0 ولا لا?
Yes, of course.
We want 0 because we want the critical numbers. This is the meaning of the critical numbers. You know, critical numbers means that the derivative is 0. Okay? Now we need to apply the Newton's methods for the derivative. Okay? So what we will do next? Salman, what we will do?
Find the second derivative.
Aha. So let's call this one, shabab, g of x. Let's call it another function. Now to apply Newton's
اسمعوا الدكتور شباب.
لا.
دكتور we can't hear you. قطع شكله عندنا. قطع عنا تمدد.
Can you hear me, Shabab?
Yeah,
I
no.
don't know what happens exactly. I was
Yes,
kicked
now
out of
we
the
can hear.
meeting. Can you slides back, Shabab?
Yes.
Okay. So what we will do, Shabab, if you, as I mentioned, it is wrong to think about the value of the function here because this is not what we want to find the zeros of the derivative, not the zero of this function. So we should work here, Shabab, on the derivative. Here, this double derivative. But to avoid this mistakes, what you will do, just work on g. Forget about f. G, that is the derivative. So this will be g at x over the derivative of g at x. خلاص. Now continue working with g, which is this function. Now what you will do, x1, what is x1? It is 0, so it will be 0 minus g at 0 over g prime at 0. And this will be equals what? Negative 0 is there. G at 0, it is negative 2. Over g prime at 0, it is 2. So what is this? Negative over negative is positive. It is 1. The value of the x2 is 1. What is x3? x3 will be x2 minus g at x2 over g prime at x2. This equals to what? 1 minus g at 1 over g prime at 1. This is equals to 1 minus, what is g at 1 يا شباب? G at 1, it is 6 minus 3 plus 2 minus 2. So what is it?
3.
3.
It is 3. It is 6 minus 3 plus 2 minus 2. So it is 3. Over, what is g prime at 1?
28.
It is
26.
20? 26.
26.
26. So now this will be what? 26 minus 3, 23 over 26. Here we are. The answer is D. And mashallah, many students, they choose D. Let me end the polling with the end of the class. So have a nice weekend, ya shabab, and prepare please for the quizzes. Try to study 4.7, 4.8, and of course 4.9. I will upload, inshallah, the slides of 4.8 if they didn't. I think I already uploaded them, but I will upload them if I didn't. And of course, you need to study Shabab also 4.9. It is so easy section. I will try to finish the slides of 4.9 during the weekend and submit it for you. Thank you, Shabab, very much. If you have any questions,